Welcome to Baba channel, and today we'll talk about Transformer. What is Transformer? We hear about ChatGPT, hear about other GPT models, Llama, Gemini, Lotus, blah blah blah. And but we are curious about how that model works, how we are giving some input text to that GPT, we are asking some question, it will give the nice answer. How it's happened? What is the fundamental technology behind it? So mostly these kind of model use transformer. So transformer, it's kind of a text generative task. Like there are multiple kind of transformers. One of that called as a text generative transformer that used by ChatGPT. Text generative transformers that model operate one of the principles that generate next token predictions given a text prompt from the user. So it will predict what would be the probable next token. Uh, in the GPT family, there are 120 million parameter used in that small model. Okay, then what would be the building block of this transformer? So what is the transformer architectures? Transformer having mostly these are three building block. First called as embedding, second transformer block, third is probability. So in the flow, for example, we are giving input text. Text would be convert in the embedding. So embedding kind of is a numerical space that that model can calculate, process it, and it will give the final output. Second block, like it will take input of embedding, transform it, process it, and giving the output. That output taken from the final output layer that will generate output probability. So I will go one by one, step by step for all these transformer architectures. First, we'll go for embedding. In embedding, there are four steps. In the step one, for example, we are giving the input text, data visualizations empower the user too. So data visualization empower user too. So the first step kind of we call as a tokenizations. The first step is called as a tokenization. In tokenization, the sentence tokenized in the words might be the one word also split in the multiple token. So data visualization empowered. Empower split by two. So this is called as a tokenizations. Second would be the token embedding. So each token have some embedding with the embedding ID, the embedding with the specific ID. So these are embedding vector and have specific IDs. LGBT2 have 50,000 to 70 unit tokens, 50,000 to 257 unique tokens. So each token has their unique embedding and embedding space also. The length of this embedding is 768. If we calculate this matrix of this token embedding, we'll call as a 39 millions parameter. So this second step. Third step would be the page positional encoding. So page positional encoding also meaningful here. So each input token position are also important. So data position is 0, visualization 1, 2, 3. So that call here the positioning embedding. Each model having handling these positional encoding different way. So GPT-2 also trained with have with internal his own positional embedding matrix. Final embedding. So this final embedding, we are just concatenating token embedding and positional embedding and creating the final embedding that calls a final output, final embedding. This embedding is input of transformer block. So in the above example, here we are passing embedding and here start transformer block. This transformer block having multiple steps. The first step, the input passed to the in the three matrix that call as a key, query, and values. So is this block having combination of this is called as a attention head. So based on the model types, for example, GPT-2 having these attention head, 12 attention head. So each attention head represent particular pattern. Pattern means here one is captures synthetic informations plus long context information. So both pattern for each words, synthetic and long context information and representation, it capture based on this. I will explain what is key, query and values here. So I already explained about transformer block. Transformer block has that multi-head self-attention in each, like for example, in step there is the key and value matrix. First is Q matrix, key matrix and value matrix. And finally computing this matrix, we are getting output KQ matrix, and this KQ, this is wet matrix is learnable. This is the learnable parameter. This wet matrix generally learning here. If we are taking one example of, for example, in the web search engine, we are doing query for particular thing. For example, find more information about it. Whenever we are querying in the web page, it will show the some bullet point. This bullet search lines called as a key, and the values of all the search line is the final values. So based on that we can understand it. Now we will understand second step where multi-head multi-head splitting. So for example, key query values splitting in multiple head. So in GPT-2 we have 12 multiple head. Each head process a segment of embedding inform independently and capture different synthetic and semantic relationships. The design facilitates parallel learning of diverse linguistic features, enhancing the model representation's power. Then it will each head perform mask self-attention calculations, and it will process to generate sequence by focusing on the relevant part of the input. Example here, key query values we are passing. Key and query here dot product. And then we are doing scaling and mask. And finally softmax. And for generalization regularization provide the final dropout and output also feed to final output we are adding here. So this is called as a one pass. Okay, so whatever I explained, same talking here. We are doing dot product of query and key, then mask, and then dropout. Final output, final output of this mask self-attention score and multiply by with the value. So final output of this sort max and values. So values multiply by with the softmax output. And then final output of this self-attention mechanism of GPT-2 passed to the MLP layer. So GPT, for example, we will take example of GPT-2 has 12 self-attention head and each capturing different relations between the token and output of these head are conconnected and pass through the linear. So all of this 12 head, here the 12 head output pass to the MLP. Here two MLP layer like linear neural network. So these have different dimension space. First, it will expand to this dimension space. Second layer again, it will come to original 768 dimension space. And it will give the probability distribution of 550,000 to 57. That is logit output. So uh, this is the multi-layer perceptron. First it will expand and then second layer it is reduced, come with the same pattern. So it's learn complete representation into the high dimension and enhance the model representation capacity and then shrink again back to for manage the dimension. Now output of this MLP layer uh, need to use for token prediction. So output of final layer, final representations into a 50,000 257 dimension space, where every token in a vocabulary has corresponding value called logit. So in this projected dimension 50,000 257, each has that probability distribution that called as a logit. How this logit control and how we can calculate final output based on this hyperparameter temperature spelling top k top b. We'll talk about it. So we will get a probability distribution that called as a logit. So temperature, simply this number divide to this logit. So if temperature is high, yeah, like temperature is less than 1, then it is increase the probability, mean you will get a deterministic output and it's sharpening the probability distributions and leading to more predictable output. If you more than 1, then it's reduce the probability distributions. That means it's more creative, more randomness we are adding it. Sample K and like top K sampling, top P sampling is very important. For example, we have output space 50257. So we will do sorting based on the probability and then we will take top K tokens only which is highest probability and filter out the less likely options. Another way, top P sampling called as a we will choose a set of uh, tokens with the threshold we are keeping with the cumulative probability, like we just combine the probability of that group and that threshold we will put okay, combined probability is this, that group of token will take it. So based on this top K sampling, top P sampling and temperature we will get the output. We need to tune it based on our requirement. So for any generative model, top K, top P, and top temperature is very important. Thank you so much for watching this video. If any questions,